Hello, this is Mark Wildman of Wildman Athletica, and today we are going to do a nerd math video. We are going to explain the math on the kettlebell snatch. Each movement that we do has its own math progression, and each apparatus that you use will probably also have its own math progression. The important points about kettlebells are fixed weights. You cannot micro-load them. They are a cast piece of metal and they don't change weight. Because they don't change weight, we have to figure out how to progress in simple mathematical ways to ensure that we are getting what we want out of our training. For snatches, the most important cycle that we can do is what's called a volume cycle. A volume cycle is very particular. We change the volume of the work that we do instead of the intensity. So let's look at the board. With our board here, we have starting points. This is a simple version of this. It can get longer or shorter depending on what you need to accomplish or how heavy the weight that you have to use is. Normally, I leave this step out, but we're gonna put it up here just for illustrative purposes. 4 sets of 5 on each side inside of a minute, every minute on the minute. This is what's called an EMOM, every minute on the minute. So you would do 4 total sets and you would do 5 left and you would do 5 right. I say 5 left because I am right-handed. You would use your non-dominant hand first. That would give you a total amount of volume on each side of your body. 4 times 5 is 20. On both sides is another 20. Add those together, you get a total volume of 40 reps. The next time we would come back, we would train again and we would add sets. So from 4 sets to 6 sets. The intensity stays the same because the number of reps we're doing inside of the minute stays the same. If you try and alter too many variables at once, you tend to get hurt, you tend not to get anywhere in training. That's why we do the math part, so we can predict when we're going to end up where we want to end up. So 6 reps times 5 is 30 reps on each side, would take us from 40 reps to 60 reps. When we go to 8 sets, we would get 80. When we get 10 sets, we would get 100. Our total volume goal for snatches tends to be around 20 sets of 5. This is just an introductory goal. 20 sets of 5 is 100 reps on the left and 100 reps on the right is 200 reps. Because we're doing this as an EMOM, every minute on the minute, we're doing 1 round inside of each minute. That takes 20 minutes. That takes 4 minutes. That takes 6 minutes. That takes 8 minutes. That takes 10 minutes. So we can predict exactly how long each day's training will take so that we make sure we can plan our day around that training. We set our goal at 20 sets because that's just a nice round number. 100 left, 100 right, inside of 20 minutes. In another video, we'll talk about a density cycle where we collapse this 20 minutes down into 10 minutes, which is our goal. 200 snatches total in 10 minutes with a weight. Once you get down to the bottom of our volume cycle and we hit this goal, where we're getting our 20 sets of 5 reps left and 5 reps right, we have 3 options. We can either do a density cycle, which we'll talk about in another video, or we will get a heavier weight and repeat the same program. Usually, people need to start with light weights. You do eventually have to get more kettlebells. You can do a lot with 1 kettlebell, but learning with 1 kettlebell is hard on most people. So if you bought a 24K, that's very heavy for most people. You would have to alter the way that this math worked and you would have to add more steps so your hands wouldn't fall apart or you wouldn't rip your shoulder out of the socket. If you have 1 heavier weight and you don't have option to use a lighter weight, then you would go and you would add in intermediate jumps. The smallest jump you can take is 1 unit. So instead of going from 4 to 6, we would go 4, 5, 6, 7, 8, and we would do every individual step. From 6 to 20 is 4-week cycle. If we added twice as many in there, that would take it to an 8-week cycle. Making the smallest jumps possible is usually the best. I tend to find if you have access to lots of weights, then you can do this faster jump. The point of leaving the intensity the same by always doing 5 and 5 for now is that your body adapts. Changing the way that your hand grips a kettlebell. Most people in the beginning when they start learning snatches tend to rip their palms open pretty severely because of the way that they're gripping the bell. The point of doing this twice a week for extended weeks and keeping the intensity the same is that your body will adapt, your hand will adapt. There's little micro efficiencies that your brain will force your body to do because your brain doesn't want to hurt your body. That's not what it wants to do. It wants to get efficient. Your hands, your skin, everything has to adapt. This is the simplest possible way to do it. So with our options, we can either go to a density cycle at the end of this, we can go to a heavier weight. If you were using a 16K, then you could use an 18K or a 20K or a 22K, and you can repeat this over and over and over again. If you have 10 weights and each one of these takes 4 to 5 weeks, then you have 50 weeks of training right there. You can get very good at kettlebells in a very short period of time as long as you do the math and you write it down. If you're just willy-nilly doing whatever, you're never going to get anywhere, but that is true of almost all training. It's very hard to get predictable results with random input. Or we can add complexity. If you only have one weight, you can repeat the math over again, but make the movement itself more complex. That is another option. That is why we're always talking about more complex movements. Instead of just cleans, it's around the leg cleans, it's high transition cleans. The same thing is true of snatches. Instead of pure competition style snatches or hard style snatches, you could do snatch around the leg, you could do snatch presses. There's a lot of different variation you can do, and that's the beauty of kettlebells. More complexity all the time. There's always more math to do. There's always more complexity to add to any one of these equations in order for you to continue to get benefit for the least amount of input, both time-wise and money-wise.